Here's some recorded examples of the solving equations with rational exponents. So here in example 2, we've got x on one side and a number on the other side, and we're trying to get rid of the exponent. So here I've got x to the 1/2. In order to get rid of that, I'm going to square both sides, and that's going to give me x equals 9. In the next one, here I've got x to the 1/3, so instead of squaring both sides, I'm going to cube both sides. That's the opposite operation. And here I get x equals 125. In my third example, example C, I've got x cubed. So the opposite operation is to take the cube root or raise it to the exponent 1/3. Those are equivalent. On the left side, I'm left with just x, and on the right-hand side, I'm left with -3. Example D, I've got x squared on the left. The opposite of that is to take the square root or to raise to the exponent 1/2. That leaves me with x on the left-hand side, and on the right-hand side, I'm going to get positive or -6. Both of those answers are true here. My last example, I've got x to the 2/3 equals 4. So the first thing that I'm going to do is I'm going to cube both sides. I'm clearing the denominator in the rational exponent first. That's going to give me x squared equals 64, I think. Let's see, 4 times 4 is 16. 16 times 4 is 64. And then my last step is I'm going to take the square root of both sides. That's clearing my numerator. And that's going to leave me with x on the left-hand side and plus or minus 8 on the right-hand side, because both of those answers are true. Whenever I take the square root or an even root, I'm going to end up with 2 solutions. Let's look at the ones that are a little bit more complicated. Here in my first one, I do have a negative exponent. So what I can start with first is I'm going to clear that negative exponent. So I'm going to write 1 over x to the positive 5/3. And on the right-hand side, I'm going to leave it the same. Now I've got a positive exponent, but it's on the bottom of my fraction. So what I'm going to do is I'm going to flip both sides. So the left-hand side is going to become x to the 5/3. And my right-hand side is going to become 1 over minus 32. So next thing is I'm going to clear the denominator in my rational exponent by cubing both sides. So I've got x to the 5, and then 1 over, what is 32 cubed? So 32 times 32 times 32 is 1 over minus 32,768. And now I've got x to the 5 on the left-hand side, so I'm going to raise that to the exponent 1 over 5 so that they cancel out. And then I'm going to do the same thing on my right-hand side. X here. When I'm taking the 5th root of a fraction, that 1/5 applies to the top and to the bottom. So I'm always going to be left with just 1 on the numerator. And then if I want to do that, I think my answer is 27 here, but let's double check. So we've got 32768 to the exponent 1 divided by 5. Not 27, but it's 8. So 1 over minus 8 is my answer for that one. Let's do example B. So first thing that I need to do is get the term that has the x in it all by itself. So I'm going to take the 10 and I'm going to move it over to the right-hand side. So I've got 4x to the 2/3 equals 100. Now I'm continuing to get x by itself, so I'm going to divide both sides by 4, and then I've got x to the 2/3 equals 25. Now I'm going to clear the denominator of my rational exponent by cubing both sides. So I've got x squared equals 25 cubed, which is a large number, 15,625. And then I'm going to take the square root of both sides, or raise it to the exponent 1/2. I have to remember, anytime I'm taking an even root, I'm always going to end up with 2 answers. So I've got positive and negative 125. This is true if I look back at the beginning of my equation. If I look at applying my numerator first, I'm going to be squaring the x value, which means it doesn't matter if it's negative or positive. Okay. So let's pause there, and I'll post another video that has examples 4 and example 5.